section notes for Unit 8. So now we're going to go from two-dimensional to three-dimensional figures. So if the scale factor between two ratios is A to B, then the ratio of their perimeters is the same, A to B. Because remember, the perimeter of a triangular prism is still the perimeter of that base. So it's still the perimeter of that two-dimensional object. The ratio of their areas is A squared, B squared. And the ratio of their volumes is A cubed to B cubed. So let's see how this plays out. So just remember that A colon B can be written as A over B. So we're looking at the numerator is A and the denominator is B. So what do we say the surface area is going to be? If perimeter is A to B, then this is going to be A squared to B squared. So this is going to be 2 squared, A squared over B squared over 9. And this is going to be A cubed over B cubed. So 2 cubed is 8, B cubed is 27. Now, going backwards, if we know the volume, and remember this is A cubed, and this is B cubed, and this is A over B, well then we cube root. So the cube root of 27 is 3. 3 times 3 times 3. And the cube root of 64 is 4. And now I can work back up to A squared B squared, which will be 9 over 16. Okay? Now again, we always want to go back to AB. So remember, this is A squared B squared. We need square root of 1 to get A, and square root of 4 and get 2 for B. And now we can go up to cubed. And you don't have to write this A cubed, B cubed every time it's squared. I'm just trying to get so you understand where the numbers are coming from. 1 cubed and 2 cubed. And again, for the last one, we're going to square. And then we're going to cube. And there we go. So if triangle A is similar to triangle B, and the scale factor is 4 to 5. So 4, 5. What is the ratio of the perimeters of A to B? Well, it's going to be the same thing. It's going to be 4 to 5. Because the scale factor is the perimeter. So we go back up here, remember it says, if the scale factor is A to B, the ratio of the perimeters is A to B. It's the same thing. And then the areas are going to be 4 squared over 5 squared. Number 2, two spheres have a scale factor of 1 to 3. Okay, so A to B, 1 to 3. This smaller sphere, the smaller one, so that's going to be A, obviously because B is bigger than A, has a surface area of 16. Find the surface area of the larger sphere. Sorry, I got ahead of myself. Okay, so the ratio is 1 to 3. If you're working with square feet area, then it's going to be A squared, B squared. So that's going to be 1 squared and 3 squared. Now, you know the smaller one has a surface area of 16, so we're going to set up a proportion and solve for x, which is just 9 times 16 divided by 1. So the surface area is going to be 9 times 16, which is 144 square feet. Hey, remember, did I go back and label the previous one? Oh, it was just the ratio. Okay. Make sure I was on track. All right, example 3. Ratio of 2 cubes is 3 to 4, 2 sides. Okay? So again, 3 to 4 is my A to B. Now I'm working with volume, which means cubed. So 3 cubed is going to be, not 9, do one more, 27, and 4 cubed is 64. So that's the area, the volume ratio. Now I know the volume of the smaller cube is 729. So we put that there and solve for x. So we're going to do 729 times 64, and then divide by 27. That gives me 1728 cubic meters. Okay, so this is how these are the steps to solve an application problem. First off, identify if you are using lateral area, okay, so 2-dimensional, surface area, 3-dimensional, but area, or volume, which is also 3D. Okay? But remember, surface area is still square units because the key word is area. All right? Then step 2, draw a picture, always good in geometry. Not a picture. And identify what you're trying to find. All right, hit pause if you need to. And number 3, solve for the variable you need. Make sure that you answer the question asked. Now, sometimes we get a number and we go, oh, that's it. And that's not actually answering the question. So answer the question that was asked. Okay, example 4. Cooking soup. You cook 400 cans of soup. At the same time, cans of soup have a diameter of 3. So diameter of 3 means a radius of 1.5. Okay, and a height of 5. Okay, so remember the formula for volume. We're obviously doing volume, trying to talk about how much soup's in the can. So volume of a cylinder is pi r squared h. So we plug our numbers in. Obviously 3.14. Our radius is 1.5, and our height is 5. That means the volume, and we're not going to round because we want all the soup we have, is 35.325. That's how much soup is in 1 can. All right? And then we need to take that times 400 cans. So that's 14 130. That's how much fluid, how much soup is in 400 cans. Now we have our big pot that we're going to be cooking in that has a diameter of 20, which means it has a radius of 10 and a height of 13. So if we do our formula again, pi r squared h, we do 3.14 times 10 squared, which is 100, times 13, we end up with 4,082. So now if we divide that into 14,130, okay? So 14,130 divided by 4,082 is 3.46. Well, that means we have more soup than 3 can hold, so we need 4 pots, 4 kettles to cook in. Okay? And the last one, number 5, we have a metal cylinder, again, with a radius of 6, so we don't have to cut in half, and a height of 18. So again, if we do our formula, pi r squared h, that's 3.14 times 6 squared, which is 36, times 18, we get 2,034.72. Now the reason I'm doing volume, again, is because it's a solid figure. And we're going to melt it down and shape it into a cone. So we're using the entire volume of the shape. So now we're trying to find the height of the cone that has a radius of 9. Okay? So we're going to use our formula for cone, which is pi r squared h divided by 3, because remember, a cylinder is a third of a cone, equals the 2,034.72 we just found. And we're trying to find the height. So I'm going to first multiply both sides by 3 to have pi r squared h equals 6104.16. Now I could divide by 2 things at a time. I'm going to take my time. I'm going to divide by pi, 3.14, and I get r squared times h equals 1944. And remember, my radius is 9, so 9 squared is 81. So it's really 81h equals 1944. So I'm going to divide by 81, and I find out my height is 24 centimeters. And that's it.